Hello everyone, I am Dr. Pallavi Ram. Welcome to my channel Probabilistic Revelations for Engineering. In the previous videos, we have seen what is a probability measure, and a probability measure should satisfy the three axioms of probability. We also saw what is conditional probability, and we have seen that it is a valid probability measure because it satisfies all the three axioms of any probability measure. So in this video, we will explore the conditional probability in little more detail. So first let us say we write the probability of A intersection M. Using this definition, we can write it as probability of A given M multiplied by probability of M. So we know that this is called as joint probability. But however, previously we saw that probability of A intersection M, if A and M are independent events, then this can be written as probability of A into probability of M. So this is joint probability for independent events. But this side, we can call this as joint probability of dependent events. Here, A given M, so probability of A given M, since it's a conditional probability, we can say that this is probability of dependent events. So that means there are two cases. Two events may be independent, two events may be not independent, may depend on each other. So if they depend on each other, so joint probability of dependent events can be written like this. And if they are independent, then joint probability of independent events can be written this way. So we'll see one example which is related to both these cases. So let us say we have a basket comprising of 3 white balls and 2 black balls. So we need to find, so we'll take this example in two different scenarios. So let us say in scenario 1, calculate probability that first draw gives a white ball and second draw gives a black ball. And we will assume that, so we'll assume that the ball drawn is replaced back before next draw. So every time we draw a ball, we keep that back and then draw the next ball. So this is the question where we need to compute the probability of first draw becoming a white ball and second draw becoming a black ball. So let us write like this. First draw is a white ball. So W1 is an event where first ball is white. And we will say B2 where second ball is black. So we need to find probability that W1 and B2 happens. So that means we need to write the probability of W1 intersection B2. Now, if we know that these two events are independent, then we can use this joint probability definition, the right side one. Otherwise, we have to use the left side one. So let us see whether this is a dependent event or independent event in this example. So first, when we draw a white ball, so we have 3 white balls and 2 black balls. So we draw it and its probability can be calculated. Now, once the ball is drawn, it is replaced back. So second time it represents to draw the second ball, it is again representing a basket with again 3 white balls and 2 black balls. So that means the event 1 has not given any dependency towards the second event. So it's a fresh. Again, you have 3 white balls, 2 black balls, and again the probabilities remain the same. So hence, W1 and B2, they are independent. So first ball is white, so hence second ball may not depend on what the first ball is because all the balls have been replaced back. So hence to write this, we'll write first the probability of white ball. So probability of white ball here will be 3 by 5. Why? Because there are 3 fundamental or elementary events which have a white, and totally there are 5 elementary events. So hence this probability will be 3 by 5. So same way, just probability of black ball if we see. So probability of black ball will be just 2 by 5. So probability of white ball is 3 by 5. I will just write this as W. Probability of white ball at any draw is 3 by 5. Probability of black ball at any draw is 2 by 5. So here, because we are asked to calculate the joint probability, we can write this as probability of white into probability of black. Because we know that W in the first draw is independent of black in the second draw. So hence this answer will be 3 by 5 multiplied by 2 by 5. So this way, joint probability definition is used to calculate independent event probability. Now let us resolve the same question, but this time we assume a different assumption. So let us go with this calculation. So this time again we have 3 white balls and 2 black balls. So we assume that ball drawn is not replaced back. A ball drawn is never replaced back. So then again we need to calculate probability of white in the first draw and black in the second draw. So question is the same, but the assumption says that the ball which is drawn out has not been replaced back. So now what is the probability? This we will see. So now let us see whether these two events W1 and B2 are they dependent or independent. Now first time when we draw a white ball, so first time, let me say first draw, there will be a total of 5 balls. And to draw a white ball, the probability will be 3 by 5. So probability of white will be 3 by 5 in the first draw. Similarly, probability of black will be 2 by 5, but we don't need black ball in the first draw, so we are not writing it. Now, second draw, when we go for the second draw, we have a total number of balls as only 4. Why? Because one white ball has been removed already, or one ball has been removed already. So out of the 4 balls, 2 are black. So hence here the probability of a black becomes 2 by, because total number of balls are only 4, this becomes 4. Now if you observe in the first draw, our sample space has 5 outcomes. So 3 are white and 2 are black. But in the second draw, our sample space has 4 outcomes. So in these 4 outcomes, the number 5 and 4, you can see that there is a change. That means the sample space here has changed. So hence, definitely, the event B2 is going to depend on event W1. So hence, in this case, to write the joint probability of dependent events, the formula will be different. So probability of W1 intersection B2. Now I can write this as probability of B2 intersection W1. So using that conditional probability, we can write this as probability of B2 given W1 multiplied by probability of W1. Now, probability of W1 stands for 3 by 5. Why? Because first draw, we are getting the probability of white ball as 3 by 5. Now, probability of B2 given W1 stands for, given that W1 has already happened, means in the first draw, we had already taken out a white ball. So that means this hole represents white 1, I mean W1 has happened. So that means W1, we can see that W1 stands for this event. W1 is standing for first ball is white. So we know that first ball is white. Already it has happened. So that means in our second draw time, we have a total of 4, out of which 2 are black and 2 are white, because we are saying that W1 has happened. So to write this probability of B2. So that means probability of B2 given white 1 means that probability of black given that white ball has been already removed in the first draw. So this time we have 2 black balls and 4 total balls. So this probability is 2 by 4. So hence the overall answer will be 2 by 4 multiplied by 3 by 5. So this answer, if you observe, it is very different from this answer. 3 by 5 into 2 by 5 here, but here it is 2 by 4 into 3 by 5. That means when events are dependent, the way of computing the probability invokes this conditional probability definition. But if the events are independent, then joint probability of independent events can be used. So overall, joint probability can be calculated in 2 different ways, depending on whether the events are independent or whether the events are dependent. So this is about conditional probability and how joint probability is computed using conditional probability definition. Thank you. If you like this video, please click the like button. And if you have not subscribed to the channel, please subscribe. Thank you again.